Hey, what's up? This is Charle Man. So today we are going to explore three gas laws: the Boyle's law, Charles' law, and the Gay-Lussac's law, each using an experiment. Let's go ahead and start with Boyle's law. So the definition of the Boyle's law is that at a constant amount of gas and a constant temperature, the volume will vary inversely with the pressure. What that means is when you increase the volume, the pressure will decrease, and vice versa.
To put it in a simple way, more heat, more volume. Less heat, less volume.
Okay, as you can see in this experiment, I made a balloon. In this balloon, the amount of gas and the room temperature is fixed. But right now, as I compress the balloon, I'll decrease its volume. As the volume decreases, I'll feel more pressure from the balloon, as I will need more force to continue to decrease its volume because the pressure increased. And ultimately, when I compress it to a maximum line degree, it will.
The second law, the Charles law, states that the volume of a given amount of gas is directly proportional to its temperature while the pressure remains constant.
So for this experiment, I first found a plastic bottle. Then I put a balloon on this plastic bottle. Next, I clapped the plastic bottle into a separate piece. I'll just call this separate piece the cap. Next, I filled 2 glasses of water, one hot water and one cold water. I waited for the hot water to cool down because there are some vapor, and I waited for the ice to melt in the cold water. Now I measured the temperature. All set, let's go. In the first step, I'll put the cup inside the cold water. As I waited for a while, the balloon shrinked a little, as you can see here. Then I put the cup inside the hot water, and as you can see in this clip, the balloon starts to expand. So this proves the law that as the temperature increases, the volume of the gas will also increase.
The last law is the Gay-Lussac's law. It states that the pressure of a given amount of gas is directly proportional to its temperature while the volume remains constant.
For this experiment, I took a pot and I filled the pot with some water. Then I heated the water and put the balloon inside. Right now, the amount of gas in the balloon is constant, and the volume of the balloon is also constant. So right now, when I heat the pot up, the temperature will increase, and the pressure in this balloon will also increase until it reaches a point where it... Okay, here are some bonus explanation of 2 concepts: diffusion and effusion. Diffusion is used to describe the movement of one material through another. To explain diffusion, I think I'll just use a familiar example that you can recall. Just imagine someone who has farted, okay? The room will suddenly smell terrible, right? But why? It is because the fart particles mix with the gas particles in the air. Effusion is used to describe when a gas escapes its container through a tiny opening. To visualize effusion, we are going to use our friend balloon again. Here, if I blew the balloon up and then I release the balloon, the gas will escape from the balloon and then it will propel the balloon forward. And this is effusion. So, to sum it up for today, we have learned the Boyle's law, the Charles law, and the Gay-Lussac's law, with also some introduction on effusion and diffusion. Well, I hope you enjoyed this video, and I'll see you in the next video. Bye bye.